Hey everybody, today I'm going to show you how to make this type of selection for an RTS game where you can click on units to select them and you can click off of them to deselect them, and you will also have drag select as well as holding shift to add units to your selection instead of just deselecting all units. So I'm going to show you how to do all of this except for the health bars and that little selection circle. But before I do the tutorial, let me dive into the theory of how it actually works. So you'll see that the corners of that little selection box UI are actually being projected into the world and setting a bounds, and if our units fall inside of that bounds, then they get selected. So let's switch to another view so we can see more of how this works. So you'll see that where those red lines intersect the ground is actually going to become the four corners of a box. That box is a mesh collider, and based on the collisions with that mesh collider, it's going to tell us which units are inside of the bounding area and which units aren't. I'm starting off with the example from our camera tutorial. If you didn't watch the camera tutorial, then you'll need a camera that has its tag set to main camera, and you also need an empty game object called event system, and you'll need that to be set to 000. Right, so we're going to need some utility functions to start drawing that rectangle UI, and I just copied this from some tutorials on the web. I'm not going to bother showing you how it works or what it actually does because it's not really relevant to the actual solution that we're trying to implement. But I am linking the code on GitHub, and I will post a link to the original tutorial. So we need a way for selected objects to stand out from not selected objects. So create a script called selection component. This is going to make our selected object do whatever we want it to. In this case, we're going to want it to turn red. To do this, we're going to get the renderer component attached to the object and set the color equal to red. We want the object to turn white when deselected, so we're going to do void on destroy, and then whenever the object gets destroyed, we're going to change the color from red to white. Now you'll see that if we attach the selection component object to units in the scene, they will turn red, and if we remove it, they'll turn back white again. Okay, now we need a way to keep track of our selected objects, so that way we don't have to loop through every single object in the game and check whether it's selected or not. We're going to accomplish this using a dictionary. So create a script and call it selected dictionary. This is going to be attached to our event system object, and it's going to hold a reference to our game object that's linked by its unique instance ID. This way, all we have to do is put an instance ID into our dictionary, and it'll tell us whether that item already exists in the dictionary or not. So first, we're going to make a public dictionary that links an integer to a game object. Next, we're going to create a public method that allows us to add an ID game object pair to the dictionary externally. What this function does is it takes in the game object, gets the instance ID from the game object, checks if the dictionary already has the existing instance ID inside of it, and if not, it'll add that game object and the instance ID to the dictionary. The last thing we want it to do after it's added the object to the dictionary is to add the selection component to the object. That way it'll let us know if it's selected or not by turning red. Since we have a select function, we're going to want a deselect function. So let's make a function that removes an item from the dictionary and deactivates its selection component. We're also going to want a function that deselects every single item in the dictionary. I'm using a for each loop to loop through every single key value pair in the dictionary. I then check if the game object for that key value pair is null, just in case the object might have gotten destroyed or something. If the game object is not null, I remove its selection component. Then, once the for loop is completed, I clear the dictionary. This needs to be done outside of the for loop. I screwed up when I was recording, sorry about that. That's it for the selected dictionary. The last thing you need to do is add it to the event system. Now it's time for the last script that handles the bulk of the work. I'm going to call it global selection. The first thing we're going to do is create a reference to our selected dictionary. Ignore the ID dictionary object in there. That's just, I needed to get rid of that, but I forgot. We're also going to create a raycast hit variable called hit. This will store the data from our raycasts. We also need a boolean called drag select, which tells us whether we're clicking on individual units or dragging and selecting multiple units at a time. Now we're going to initialize our selected dictionary object by using getComponent to get a reference to the selected dictionary component that's attached to the event system. And we set drag select to false. Alright, now in update we're going to decide what actions are taken when the mouse is pressed. Okay, so we're going to need some variables to store our mouse position, so create two vector3s called P1 and P2. Step 1 is going to be to check if the left mouse button was pressed down, and whenever that happens, we're going to set P1 equal to input.getMousePosition. So now whenever we click the left mouse button, our mouse's position on the screen is going to be saved to that P1 variable. Step 2 is going to be checking if the mouse is currently held down, and basically this will tell us if we're dragging and selecting, or if we're just doing a single click. So we're going to do input.getMouseButton0. So now we're going to get the vector between where we first click down on the mouse and where our mouse currently is. If the magnitude of this vector is larger than a certain number, then we know that we're not just clicking on one area, we're clicking and dragging to select multiple units. This number is going to vary. I suggest playing around with it. And inside of that if statement, we're going to set drag select equal to true. Okay, so the third and final piece of logic here is going to be what happens when the mouse button is released. So we do if input.getMouseButtonDown for mouse button 0, which as you probably figured out by now is the left mouse button. So the first case we're going to implement is the simpler case, which is if we're clicking on a single unit. So we're going to check if drag select is equal to false. This next piece of code we're creating is going to create an array, which if you don't know what array does in Unity, it's basically a vector 3 with no magnitude. And this array is going to point from our P1 position on the camera into the world. Next, we're going to check if there are any collisions by doing a ray cast. What this is going to do is this is going to scan out along the ray for a specified amount of distance until we intersect with a collider. And then that hit variable that we created at the beginning of this part of the code is going to return whatever the data from that collider is. Alright, so now that our ray cast has hit something, hopefully a unit, we're going to check whether we're in inclusive or exclusive selected mode. Holding down shift is going to let us select multiple units by clicking on them while holding shift, and just clicking on units individually without holding shift is only going to select that unit. The way that we check for whether shift is pressed is just the same as the mouse button. We do input.getKey and then check for keycode.leftShift, and the difference is when we're doing an inclusive select, all we do is we add the selected unit to our selected table, and when we're doing exclusive, we deselect everything and then we add the unit. In most RTS games, you can deselect units by clicking on the ground. We're going to implement that as well. Whenever our raycast doesn't intersect anything, we're going to deselect every single unit from the table, unless we're holding down left shift. In that case, we're not going to bother doing anything. If you want your raycast to only intersect with certain things in your game, like let's say you want to be able to select units, but you don't want to be able to select the ground, what you can do is you can add a layer mask to your raycast. The layer mask will make sure that it only interacts with certain layers in the game. Alright, so now let's add this global selection to our event system and see if we can select single units. I forgot that my infantry units here didn't have a hitbox, so I had to add a hitbox to them, which made them roll around on the floor, but as you can see, selection works now. Alright, so now we're going to need to add a few more variables. We're going to need to add a mesh collider and then a mesh. This mesh is going to create the bounding box that we saw earlier, and the mesh collider is going to handle collisions. The last two things we're going to need is an array of vector 2s to store the corners of our selection UI box, and an array of vector 3s to store the vertices of our bounding box that we're going to create in 3D. So let's go down to the bottom of our script and add an onGUI function. We're going to be using that util script that we created earlier in order to draw the UI for our bounding box. So if drag select is true, we're going to draw a rectangle with corners at our P1 and the current mouse position. We're actually drawing two rectangles because there's an outer rectangle and then there's a colored fill on the inside, and they have slightly different colors. So now if we save all and go and run the game, we'll see that we have a selection box that won't go away because we have some broken logic, but we'll deal with that later. Before coding this next part, I need to explain how it works. So let's say that you drag across the screen to select some units, and you start at P1 and you end at P2. For the sake of drawing triangles for our mesh, we would want P1 to stay the same. This top right corner would become P2, the bottom left corner would become P3, and the bottom right corner, which was originally P2, would become P4. The reason for this is so that connecting the dots in this order gives us this Z-shaped zigzag pattern. Now let's say that P1 is in the bottom right and P2 is in the top left. This would be if you dragged from the bottom right corner of the screen and released your mouse when it was at the top left corner of the screen. In this case, for our zigzag pattern to work, we would need to swap the positions of P1 and P2. Alright, so now that you understand that the entire point of this function is to make our P1 and P2 and P3 and P4 play nicely and form a Z, I'm not going to bother explaining all of the different transforms in detail. Just know that if you give this thing 2 points that define a rectangle, it'll spit back out the 4 corners in that Z order. Now that we have our 4 points defining our 2D rectangle, we want to create a cube. So the way that we're going to do that is we're going to take that rectangle and copy it, but move it up the y-axis by some amount. Then we're going to draw lines connecting all 4 of those points to their corresponding 4 points above them. We then connect these points to all of the other points on the plane that they need to be connected to form the box, and voila, we got a box. So the number of all those vertices has been reduced by 1 since arrays are 0 indexed on computers. Well, unless you're using MATLAB, but that doesn't matter. To turn these vertices into a mesh, we need to describe triangles using the indices of all of these vertices. Triangles have to be drawn in a certain winding order, so we're going to need to connect 0, 1, then 2. Then we're going to need to connect 2, 1, and then 3, and so on and so forth until we have the box drawn. I'm not going to explain that part either. I'm just going to show you the winding order of the vertices that I have in an array, and you can just copy it by hand. Here I am coding up the function that creates a 3D box from those 4 vertices that I gave, that I just explained in the MS Paint example. I'm going to give a freeze frame after I'm done talking so that you guys don't just have to watch me like code in time lapse. We also need to define the onTriggerEnter function. This is going to be triggered whenever an object enters that cube, that mesh collider that we're creating, and this is what's actually going to detect intersections of our cube and our other objects that we're trying to select. And whenever this event is called, we're just going to add the game object that we intersect with to the selected table. Alright, so this is the very, very last part. We're almost done. But basically what this part is going to do is it's going to take that 2D selection box that we're drawing on the screen and use those corners to draw the points of our 3D cube onto the world. So we have that little if statement that says if drag select equals false. Now we're going to do the else statement, which is going to be activated if drag select is true. So now we're going to initialize our verts variable to an empty array of 4 new vector 3s. And we're going to do int I equals 0 to set a counter that starts at 0. And we're going to set p2, which is the place where we're letting go of the mouse, equal to input.mousePosition. Now our corners array of vectors is going to be set equal to what comes out of the getBoundingBox function, which, if you'll remember, is the thing that returns p1, p2, p3, and p4 in that z order. And now for each of those corners that we get back from that function, we're going to do a raycast from the screen position out into the world. And that's where those red lines that intersect the ground and form the corners of our 3D bounding box are actually going to be generated from. So when we do our raycast, we're going to set our layer mask to 8, which 8 just so happens to be the layer of the ground. So this will only intersect the ground. Now at each of the points where our red line intersects the ground, we're going to add that location to our array of vertices that we're going to use to draw our 3D bounding box. And then we're going to increment our counter at the end. So now using this array of the 4 vertices where our lines intersected with the ground, we're going to generate that box mesh, and then we're going to set that mesh as the mesh of our mesh collider. So we generate the mesh using that function that we created earlier, and now we're going to do add component to add a mesh collider to our game object. We now set the mesh of that mesh collider equal to the mesh that we just generated a second ago. Now we're going to make sure that our mesh collider has isConvex set to true and isTrigger set to true. And this is just going to make our lives a lot easier. Now we have to check if the left shift key is being held down. If it's not, we're going to deselect all objects before we add the objects back to our selected table. And if it is held down, we're just going to do an inclusive select and keep everything currently selected and also add the new objects as well. Now we're going to make sure that our selection box is destroyed after 1/50th of a second, or I think that's around 1 frame, I'm not sure. But this way, the box doesn't stay in the world and continuously select things as they pass through it. Lastly, at the end of our update function, we're going to need to set drag select to false. This way, whenever we're done selecting something, the UI will go away, and it won't linger like it was earlier in the video. Now that all that's over, we can hit play and finally enjoy the fruits of our labor. Wow, isn't that neat? You can select little guys. Cool. Thanks for watching, everybody. I hope that I explained this in a way that makes sense. I really wanted to explain the whole concept behind how it worked rather than just have a bunch of code up on the screen for you to copy and paste. But speaking of copying and pasting, all this code is going to be on GitHub or somewhere. I haven't decided yet. But once again, thank you for watching. I plan on making more of these in the future. Cool.